To be continuous,
The limit from the left.
there's three things.
Yeah.
Oh yeah, there's three things.
Three things.
The limit from the
First,
Point is defined.
the function has to be defined. There has to be a point there. Second,
Second,
the
limit from the left.
limit from the left, limit from the right have to be equal to each other. The third thing, this is the important thing, Andrew. We've established the function is defined. We've established that the limit exists. The third thing.
The limit as x approaches the point equals the.
Right, however the function is defined at the point is equal to how the limit is what the limit's equal to. So when I run through my analysis here, is f of 3 defined? Sure, I'm going to get 2a minus 6, that's okay. I then have to check the limit as x approaches 3. Because I have a piecewise function that breaks at 3, I have to consider from the left and the right. Here's the thing though, Polymon and friends, you better be telling me what direction you're coming from, and it better match the function. It better match the right piece. Limit as x approaches 3 from the left is negative 2. Limit as x approaches 3 from the right is 2a minus 6. I want the function to be continuous, so it has to be true that these two things are equal to each other. I'm going to set them equal to each other. I'm going to solve, and I'm going to get a is equal to 2. These are the things. Missing any one of those parts means I cannot and will not offer you full credit. Other things to look out for. If the name of the function is g and you're calling it f down here, I'm going to withhold a point. If the variable is t and you're using x, I have to withhold the point. I just have to. Alright, B asks about horizontal asymptotes. You all know, and you know very well, that horizontal asymptotes we're talking about end behavior. I've got to figure out what happens as I approach negative infinity and what happens as I approach positive infinity. Now, I was mean on this one. Your piecewise function is defined differently at the two ends. So you have to tell me limit as x approaches infinity of this function. I hope this is the easy part. Right? We just 1/3. Don't have to think about it. Degree 2, 3. Maybe we should think about it. Your limit is 3. The 3 is not the answer because I'm asking you a horizontal asymptote question. Andrew, I need to see a horizontal asymptote at y equals 3. That's the conclusion. Aaron, you okay?
Yes.
Good. All right, now the second one, you've got to take the limit as x approaches negative infinity. This is not a rational function. I cannot plug in any of the infinities, so we have to have our conversation about like, well, what's happening to the function? As x approaches negative infinity, the exponent approaches negative infinity. E to the negative infinity power gets closer to 0, so this whole sum gets closer to negative 3. Conclusion, horizontal asymptote at y equals negative 3. We're good? Good. All right, part C. Part C. What did I ask for here? Discontinuities. If I'm looking for discontinuities, right, where is this function going to have discontinuities? Where might I have discontinuities? Lewis, where might I have discontinuities?
X equals 3 and x equals 8.
I might have a discontinuity at x equals 3. I might have a discontinuity someplace else. There's some other place to think about a discontinuity. I see you, Lewis. I'm just ignoring for a little bit. Look at this piecewise function. There are 3, maybe 4 places where I would hope are pretty obvious that you might have a discontinuity. You might have a discontinuity at 3 because the function is defined differently from the left and the right. Another place. At 8, I should be checking continuity here at 8. Other places where I might have a discontinuity.
1.
Wait, no.
Less than. No, nothing. Less than negative 1.
Okay. This first one is an exponential function. One of the things we talked about in this unit is polynomials, exponentials, trig functions are continuous on their entire domain. Could this first part be discontinuous anywhere? You've got an exponential function. Exponential functions are either like doing this thing or they're doing doing that thing. Could exponential functions be discontinuous? No, I wouldn't even bother checking. This guy over here, the square root function, you guys know what that looks like, right? It looks like that, or maybe it looks like that, or it's been shifted. Continuous. The only place I might have a discontinuity, hold on,
As at x equals 10.
what I should be doing is I should be focusing on the denominator, right? Because the denominator is where you have these candidates for discontinuity. So I'd set the denominator equal to 0, I'd solve it, I get x equals 0, and I get x equals 10. X equals 0 is not in the domain, so throw 0 out. So the work that I did from there, let's see. All right, we've already handled continuity at x equals 3. At x equals 8, I went through my process, found f of 8, found the limit as x approaches 8 from the left, found the limit as x approaches 8 from the right. Whatever this is, it's not 0. So my function's not continuous at x equals 8. Okay. And then the last part for that function where x is greater than 8, I set the denominator equal to 0. It's going to be 0 and 10. So I'm going to take the limit as x approaches 10. I get 300 over getting close to 0. That's one of the infinities. If you have a candidate and your limit is approaching one of the infinities, your conclusion here is a vertical asymptote. If it had been a number like 7, 5, negative 12, your conclusion then? Whole. If you have a candidate and your limit is getting closer to some number, you have a whole. All right, then Stephen, eager beaver that you are, thank you so much for your email last night at 11:11 when I was asleep.
Making a wish.
Yeah, I made a wish. I made a wish. It was keep sleeping. Okay. You can email me at any time that you want, and that's fine. And I think I emailed you back at like 4:30 this morning because that's when I get up. All right. That's it. Why not? That's my time. All right. So part D. Part D asks, can we use the intermediate value theorem on the interval? Was it 9 to 12?
No.
And the conclusion here. There is only one conclusion to make here.
No, you can't. It doesn't.
No, because. Oh, I stopped listening. Did y'all hear it? He said it. That doesn't even make sense to me. Doesn't even make sense.
Is not continuous.
What are you talking about?
The function is not continuous on 9 to 12 because we have a vertical asymptote at 10. So you can't use the IVT. Yeah.
I thought you meant like if it was
Yeah.
could you do it? Because that's how it was phrased like that. If you
Oh, sorry.
if it was
Does the intermediate value theorem apply to f of x on the interval 9, 12, guarantee that f will have a root on the interval? And you read it as like, if the function was continuous,
How would you?
could we use the IVT?
Yeah.
if you use the IVT, could does there have to be a 0 between that?
I read it the way
Okay.
you said.
But here's the problem.
It's not. I know it wasn't.
You cannot use the IVT because you have to first establish continuity. Does that make sense?
I read it the way you said.
Yeah.
I assumed you said you would ignore the vertical asymptote at 10.
Okay.
And then I explained that since it does pass from when you plug in 9 and 12,
Yep.
you end up getting the opposite numbers, so it has to cross through the.
Okay. I hear on that. Here's what I care most about with the 11 of you all. Does it make sense that we cannot use the IVT?
Yeah.
Everybody's okay with that? Okay, if the question was phrased in a confusing way, let it go. Just let it go, it's gonna be all right. Okay? But if you're gonna use the IVT, the function has to be continuous. If it's not continuous, cannot do it. Cannot do it, just get out of that problem. All right, and then part E, this is the one where Polymon came in. It was the saddest little story I've ever heard. He tried this, he wanted his notation to be like top shelf, and no one was able to do it. And I'm not
It
sure
was the second one.
Oh, I used it. Oh.
What?
But the
The domain restrictions don't let that.
show that for all values of x with 3 less than x less than 8, that
It
f
just
prime.
says x less than 3.
Excellent.
It just says
The
x
question
less than
is-
3.
Oh, yeah.
Come on. No. Oh, that sucks.
Yeah, no wonder. I still did it.
Wait, are we right?
Are we right?
Wait, so based on what you have on your paper,
Can't be done because it don't make
if you want to use that as your primary source,
Oh, that's weird.
okay,
What'd you get?
right now,
I didn't do it.
right now you all do not know how to find that
We used
derivative.
whatever we could.
You used
I got, it was like 3
What'd you
natural
get?
3, right?
I got 3 over natural.
I didn't even finish the
3 over natural.
Steven, when you went to Wolfram Alpha, what did Wolfram Alpha tell you? Good answer, you didn't go to Wolfram Alpha because we've had this conversation. The derivative of -3 plus e to the x minus 3 is e to the x minus 3.
Oh, I did.
There is, you would not know that at this point. I made a mistake. Earmuffs. I made a mistake. All right. So here's the thing. Here's the thing. I am going to pick this up, and I am only going to grade A, B, and C. I am really interested in the notation here.
What did you say the answer?
What did I say the answer was? The derivative for what you're reading would be e to the x minus 3. So I need to make the change on the handout. I'm so sorry about that. All right, whoever my paper picker upper is, if you could please go pick up the paper.
Why did you?
I am only grading A, B, and C. And friends over here, Polymon mentioned that for whatever reason I'm blocking your view a lot. Sometimes.
Like when you step to this side. Like
Okay,
the whole side of
if the 4 of you would rather like sit over there in that section or back there, whatever works for you all. If this is not the right place for you to sit, feel free to move. Okay? King Louie, you all right back there?
Yeah,
All right. Giselle, we're okay? All right. I am
They still
curious.
saw you.
I am curious. First unit test is tomorrow. On a scale of 1 to 5. 5 being, I hope to get attacked by a bunch of spiders tonight so I don't have to take the test tomorrow. Okay. 1 being, I'm good, this is going to be a good experience. How worried are we? Be honest. I'm seeing 3s, I'm seeing 10s. Okay, you've got spider venom going through your body, so you don't really know.
She's not used to it.
Okay, 3. I would say you should be in like the 3 to 4 range. If you're at a 1 or a 2, if you've been rocking it all throughout the last 3 weeks, then fine, be at a 1 or a 2. Tomorrow's test is going to be hard. I want to let everybody know that right now. It is going to be hard for 2 reasons. Number 1, it covers absolutely everything we have studied for the last 14 lessons. And there are questions that I'm going to push you in ways I haven't pushed you before. 60% of the grade is based on multiple choice. Polymon is really looking forward to that part because I'm not going to look at your notation. I'm just going to be like, did you circle the right answer? You're going to have to move fast. You have 14 questions to do in 30 minutes. That means 2 minutes per question, like max. The questions don't necessarily go easy, medium, hard, impossible. They're kind of like sprinkled, okay? So if you get to a question that you're just like, man, I am stuck, I don't know what to do, my advice?
Skip it.
Skip it, move on, put a little star next to it, be like, hey, his last name begins with a D, maybe that's it. My first name begins with a K, hey, maybe that's it. Okay, I do have an ego. The last 20 minutes is free response. That is 40% of your grade. For some of you, you're like, oh, this is where the angels whisper to me and you hear the hallelujah chorus and everything is good because your notation is solid. At this point, Polymon, you're going to like, annoying little brother, keep writing limits, keep doing all the things. I am going to be ruthless on the free response. You just need to know. It is very likely that for the 11 of you, for the first time in your life, you might not actually finish this test early. Carmen, it's going to be okay. Okay? This is Calculus BC. There is going to be a curve. I'm not saying how much of a curve there's going to be. I need to see the data. For those of you that have had a poor quiz performance, the quiz will disappear. If you have made the corrections and done the things, that quiz grade will disappear and a better grade will be put in its place. My goal is to have the tests graded tomorrow, but I need to get the data from North Central and Southeast so I can set the final curve. This test grade will go in my grade book this weekend. I'll send you guys an email when it's like final, and the grade that you see on the Home Access Center is the grade that's going to go in the progress report. So if you're not happy with that progress report grade, here's my advice as a parent. Be honest. Let them know, hey, Calc BC's been really hard. I've got this 82 as an average, and I know you expect all A's out of me. Like, I'm going to get there, but an 82 is a respectable grade. It really is. In the Calculus BC class, it is. As long as your last name's not DeRocher, an 82 is just fine.
You can get mad at me.
Exactly.
Shut up.
Exactly. You're like, so Mom, what do you think about the intermediate value theorem? What are your thoughts there?
I think that was business, so she left me alone.
All right, so I think you all should plan to spend at least an hour tonight studying. Okay, but no more than 2 hours. No good will come from your cramming all night long. Andrew, do not stay up all night. Okay? I'd say at least 1, no more than 2. And there's all sorts of research out there that the best thing you can do the night before a big exam is get a good night's sleep. Chunking, like 30 minutes, and then like go for a walk. 30 minutes, and like watch something on TV. 30 minutes, go catch some Pokemon. 30 minutes, color your hair again, Aaron. Whatever you want to do, like small chunks is the way to go. So I want to stop talking, and I want to give you guys a chance to read through the do's and don'ts here. And let's take attendance.
Why don't we
We're getting better. I care about the growth. And we're reading. Make sure you understand what's in the don'ts column. The don'ts column is all the bad things to do tonight. Thank you. Does anybody have any questions about the do's and don'ts here? Aaron?
Do you have, are there any like problems that you would recommend us like doing?
Why? What
I
a
don't know.
great question.
Oh, they said why? Like
No, I wasn't done there. Okay. Do I have any problems that I would recommend?
I'm so sorry.
God, like, if there were problems that I would recommend that you would work on. If only I had thought that far ahead.
I already read the do's and don'ts.
I know. All right. So here's the thing. So I put together some multiple choice questions. Some of the other calculus teachers submitted questions as well.
Only you had flipped the page.
Yep. If you look on pages 8 and 9, I put together, released, these are the free response questions from last year's test and the scoring guide. So not just like the answer, but like the work I would expect to see on a question like this. Okay? Strongly recommend working through the problems that are on here, and I'm going to give you guys most of the rest of the class to do that. Aaron, in terms of other things that I would recommend, the 2 quizzes. Any of the multiple choice questions that you got wrong, I'd get together with somebody, talk about it, figure out what's going wrong. Free response, it's great practice there. Quiz 1 and quiz 2, and anything that I have given you that is titled journal. The journal entries are the key to success in the free response. They are such the key to the free response that once class is over, I'm going to send you all my worked out solutions to all the journal entries and my worked out solutions to all the problems that are in here. Okay? Any other questions about do's and don'ts? Do what? I'm not picking this up for a grade. I'm never going to know if you did it or you didn't do it.
You said we have to come back.
Of course you have to come tomorrow unless you were attacked by like a horde of spiders. No, I said horde. It's going to take more than that. Alright, last thing before you guys like switch into like work mode. In the unit packet, I don't know that I ever like formally called attention to this, but Miss Cooper, who's at Southeast, was kind enough to put together all the vocabulary terms in one place for you. Then I added on to that what the College Board calls all the essential knowledge and enduring understandings. I really think it would be worth your time to read over all the things on pages 3, 4, and 5. Grab a highlighter and just start marking it up. Like, do I know this? Do I have a question about it? These are not problems for you to work through, but it's like the big ideas. Do I understand all the things? Okay? So, here's what I'm going to do. You guys have the next 30 minutes. I think the smart thing to do is spend some time looking over the vocab, the essential knowledge and the enduring understandings. Make sure you know that. And then I would advise you to make a choice. Do you want to spend the time working on the multiple choice part of this packet that I gave you? Or do you want to spend time working on the free response part of the packet? If notation has been a problem, free response would be the way to go. And I'd like the free response friends to move like to one of these 2 tables in a little bit, because that's where I'm going to spend the majority of my time. Multiple choice people, I want you to stay in the back and you guys can work with one another. Free response people, stay up front and we'll work through 1 or 2 problems together. Okay? Maya, are you good? Okay, the rest of the time is yours to use in smart, productive ways.
I need to figure out what second grade. No, I'm going to figure out how I'm going to.
We'll put a roll, we'll put a roll.
North Central friends, this is probably going to be the end of the video that you should watch. I'm going to keep the camera on because maybe something special is going to happen, but I think not. I think everyone's just going to be working on problems and getting support. Enjoy the ride. You're in good hands with Mr. Similar. Aaron might do a cartwheel apparently. You guys are going to do fine on the test tomorrow.
The thing is being recorded.
Okay, there are highlighters in the supply kits if you need them.
Yeah, I'm going to do it.
Aaron, that was too funny when you asked that question. Are there any problems you'd recommend? Yes.
Miss, you listening to instructions, you didn't read ahead.
anything as you're reading that doesn't make sense, just let me know. That's the only difference. Difference quotient is another way to say change. It's another way to say secant line. It's just another like vocab term that's in there. It's when you take the limit of two.
Do you get it fixed?
The derivative is a velocity component.
Should or
Difference quotient would be like
your
your
bone
average
value.
But it'll
velocity.
never equal 2 though. Your bone never equal 2.
Okay.
You're very likely go. That was on the
Fingers
left side of your
like
mouth.
Right?
That's how you go. That's how you go into like the vocabulary and the essential knowledge side. No. Okay. How we doing? Okay. So the graph of the function f shows up. Which of the following statements about f is false?
I thought that this was mine.
And so you're saying. Wait.
I was assuming that this was mine. Well, this doesn't even have mine.
Okay. Correct. Which one's false?
Where is not.
What does it say?
My grade because my high account is not working.
Oh, okay.
Why is it not working?
He gave me the password again. No, I went to the next one.
Oh, it's
I think they asked you.
So will it ever be like this where the point isn't like it's not labeled?
My logic
We just have to like assume.
Yeah, assume the scale here is 1.
I know, but right here I was confused because this doesn't even have 9 points on it. I think that's why it's not. We just type an end of the graph.
Well, no, that's why you need to be careful here. You're taking the limit as x approaches 9, but where does that x go first? Right.
So it's f of negative.
I mean, E makes sense too. E makes more sense.
Okay, yes. So as x approaches 9, what happens?
Oh, this gets closer to negative. Well, this becomes
Right, what happens is as x gets closer to 9, g, because g is negative square root of x, is getting closer to negative 3. So what's f of negative 3? What's happening on the graph of f when you get closer to negative 3? Well, hold on.
Well, where you go down?
As you're approaching negative 3, so what's the answer then? Right, because we're still asking the limit question. Now, chain here. This is not a function.
This would be a.
If both dots are filled in, it's not a function. One of those should be a function.
So we're from time to time, like we're gonna have to label these.
For the college board, you will not have to.
So these will be labeled.
Yeah, it was one of the other teachers made this one.
Okay, like, this is like really confusing.
Yeah.
And
And I'm not like throwing monkey questions. You did a great job making these questions, but this is the first time we're using these questions and it shouldn't have been defined. So. What'd you guys get from the first one?
I just went to this one first, but they talked about it. This one's really easy.
Okay, I think it's 8 to the 140.
So x approaches pi over 2. What happens to this? This graph.
Yeah, this is a so this is 5/2
Right, because the cosine, on the cosine graph, if x approaches pi over 2, then the cosine has to approach 0. So now you're evaluating f as you get closer to 0. What's happening there? You're approaching 0 on the graph of f.
It does not exist.
You would find like no way, so that's not why you
You get
like
closer
look
to
at
0 on the graph of f.
so you would identify those.
Should be positive 1, right?
And then
No. Here, it's okay. Watch. Exactly. In this case, as you approach 0 from the left and 0 from the right, both y values are getting closer to 1. Turns over here. How would you like? Yeah. Parameter, like when we were back in the day, we were doing some stuff like what's the limit as x approaches infinity of like a times e to the negative x. There's two variables here. There's the x and the a, but you've got the variable that's changing, and then this guy over here, the other one, is what we're calling the parameter. It's a variable that you don't know.
It's like 20. That's still 11 chapter.
Yeah.
For the first one, where she's showing me from the word.
I mean, the answer.
Both of them make sense.
You just find the values.
Okay, what do we have about the graph?
That it just function 2 from all the functions.
Wait, one more time.
It approaches 2 in all the functions.
Well, okay, for x is greater than or equal to 0, the horizontal line y equals 2 is Okay, so end behavior says, as I'm heading out towards infinity, the graph gets closer to 1. Okay. That's what this one says. That is not what this one
you can
says.
see the outline of the
Ah, you're saying this one as well? Okay. One of the things that we've talked about, and it's tough because there are no examples of parent functions that do this. It is possible for a graph to cross the horizontal line. Because with all right, remember horizontal asymptotes, what you're talking about is end behavior. What happens at the end, no promises about what happens in the middle. It just tells you what happens at the end. So that's why E is the answer. B, it could happen. Okay. David. I would love to. So that they are pretty much the same idea. Okay. So here's the graph of F. We've got the graph of G. What's the limit as x approaches pi over 2 of f of g of x? Well, as x approaches pi over 2, what's happening? Let's look here first. X is approaching pi over 2, so I might write it this way. As x approaches pi over 2, tell me about g. What's happening there? G is the cosine. But hold on, yes, the graph oscillates, but as you get closer to pi over 2, it does something very specific. What's the graph of your cosine get closer to? Yeah. Okay. G of x gets closer to 0. But what happens to f
I
of
feel
g of
it
x?
doesn't make sense.
If this part in here is getting closer to 0,
This still be
what happens on the graph of f as you get closer to x equals 0?
It'll still be.
And I want to be careful. As we're getting closer, we don't actually get to pi over 2. X gets closer to pi over 2. G of x gets closer to 0. What happens on the graph of f if this guy here is getting closer to 0? Closer to 0 from the left, closer to 0 from the right. What are we getting closer to? We're getting closer to. Is it? Yep. Oh. Okay. My work here is done. Friends back here, how are we doing? Okay.
And I will send you all the workout solutions for all of these. It won't just be like the answers, but it'll be like workout answers. All right. You're welcome.
Then, when f g of x, so what is supposed to be 0?
I promise you will be asked to show.
52 out of 80.
What is it hard? I mean, you stick the limit for both sides.
That's not right. It's not that it's hard. It is very specific. It is so specific with very little wiggle room.
So would this be a good answer? I put yes because the limit, as I said, it approaches 2 from positive and negative.
But that's the thing. That's not enough. There, if you're going to show the function is continuous, I need to see 3 things. You're only telling me about 1 of 3 things there.
Well, normally I show it.
Right, so you have to show me that. You have to show g of 2 exists. I don't need to see g of 2 is, 2 minus 5 over 2 minus 3. You can just tell me g of 2 is whatever number it is. Right, if you can like in your head tell me g of 2 is 3, great. That's step 1. You have to show that step. And then you actually, you find the limits. Don't just like tell me, show me.
Like the work for it, yeah.
Right, limit as x approaches 2 from the left of g of x equals blah. Limit as x approaches 2 from the right of g of x is blah.
And then I can do it.
Right. And in fact, if you checked that g of 2 is equal to a number, and the limit as x approaches 2 from the left is that same number, and the limit as x approaches 2 from the right is the same number, as long as I see those 3 things, that's enough for you to say, oh, the function is continuous. Right, because they're all the same number. It is safe to just say, yeah, it has to be continuous. Steven, you okay?
Yeah.
And Stephen, I appreciate your emailing me with that question last night. And it was at like 1 o'clock in the morning, I get up to like, and I looked at my phone, and I'm like, oh, Stephen sent me a question, and I'm like, it's 1 o'clock in the morning, the boy can wait till 4:30. I was afraid that was going to be the case.
Oh, you did the same.
Or like sleep.
I did the same thing. Because you went straight down right here.
That's a lot for you, or?
He's like, yes, sir.
That's normal for us.
Like seriously, how much time at home?
In the first country.
Probably like that.
Okay, fair, because you procrastinated, but like, that's not a,
Except
every.
for the record, you show that.
Every other. I mean, they're bad days, and like being in BC, that's like 45 minutes.
Wait, what?
As g of x.
This weekend, there will be no, this is a great
Right.
gift.
So,
There will be no homework this weekend.
As g of x.
I'm a
We're all
Yeah.
What's the problem?
Yeah.
Oh,
for real, we almost did it again.
Close to x.
Right, in this case, so like the write-up would be something like, as x is approaching 9, g is approaching -3,
But that means that f of g, we're asking what happens on the graph of f when I approach -3. The limit from the left and the limit from the right are different. Conclusion, the limit doesn't exist. And as I pointed out to those guys, and I didn't see this, one of these needs to be an open circle.
So f of
Right, otherwise it's not a function. And the universe explodes.
True.
it's nice. So you would write f of 0.
Oh, yes.
Equals 1.
Equals 1. Or you can just write this all out. Even if you plugged in like, you can just look at the -3 to 2 to 1. -3 to 1 is not going to always do that. Because there's 7 to 9 meanings that I can't tell. 2, 1 to 2, definitely not. See that? 1 is just going to be negative. It's going to be -4, -2. All of the other things take 1. Okay, if I had it, like, because I can do it fast enough, I would do it. If I had the time, which I probably wouldn't. Because what people used to do is try to avoid all the intervals. But that's it too, right? Because of the times they're going to explain I know it wouldn't be, but I'm trying to figure out
Evaluate g of -3 and g of 2. Yeah. Based on your answer, your conclusion in 2a, is there a c in that interval where g of c is equal to 0? Why not?
sometimes I know there's not. Just by looking at the interval.
Okay, but here's the thing. In part A, frequent functions at 2 and x equals 2, the function is continuous. On this, what do you get?
That's doesn't it?
Why would you do this?
Because if it's continuous, it's going from 0 to 3x. X got negative 3x.
Yeah. Because the graph of g is continuous on that interval, which you've already proven, because the graph of 7 minus x squared it is already continuous. And you have continuity at the endpoint. You've established continuity on the interval, which means you get to use that. G of -3 is a positive number, G of +2 is a negative number.
Because it's greater than or less than.
Right, but the idea is to establish continuity, check the endpoints.
Yeah, because negative,
You can see.
Time goes by so slow in this class.
No. You didn't hear at the beginning of the sentence. I said said that as soon as you let us go to class, my advice was when you're teaching.
The next thing is two right here. It looks like that. It's not how it's gonna fit. No, I see.
Yeah.
The reason that you check the entries is you need to see, is the number 0 in between the units? So tell me, is the number 0 is it well, you're -3 and now don't lie. G of -3 is a negative. G of 2 is a positive number. So this statement, because this is true, now your conclusion is there is a value, or you say G of C equals 0 at least once.
So instead of say the value.
They should be f plus h minus f of x over h.
Is there a flood coming? Oh, this is so well put together. Maybe it's just because I am a 7th grader and our projects don't come out this well. Sorry, but it's true. It's true. Are you in art honors society? No, then it's like an average then. Yep. So David, what are you focusing on?
Make a friend.
I was doing it right now.
That's pretty good. Yeah, I'm like, bye there.
I'm gonna do it with love.
Yes.
Yeah, absolutely, absolutely. Hey.
Your phone, your phone, your phone.
You don't need to know what the derivative is. Alright, Aaron.
Another one back. Oh wait, I didn't do it. Do it again.
It's not that you're plugging in the points into the calculator, you're plugging
What are you doing?
Cardio.
Oh my God, okay. My bad, you clearly warned me earlier. I did not take that as like, I'm actually dumb enough to do this on film, and I can show it to your mother. I can see how that is my fault. We'll be talking later, Mrs. Hawthorne.
Now I have a reason to watch the YouTube video.
That was it.
I see what you're saying. I'm basically asking for a way to
Oh yeah, that's not.
It's gonna be f of a plus h minus f of
I believe so, but it's on one. Which one? Oh, this one.
No, we were talking about it.
You don't have to.
So basically all it's asking is when the slope is 0, when the slope greater than 0, when the slope less than 0.
Correct. And so if you have that function graphed in front of you, right, how are you going to know that the derivative is positive? What would you be looking for in the graph? You're going to be looking for the graph to be increased, right? So that's why I want you to have it on the calculator, because you're going to have to do things like, where is the maximum, where is the minimum, and like find the interval.
Yeah, because
But that's all calculator stuff.
no, because I think the other one that x plus
So have you spent some time, Andrew, on the free response?
no, I didn't do it.
Okay. And like I said, I'll send you guys the
But you can
solution.
use the symbols for your notes. Both of them should work. Both of them should work.
I find the other one.
minus 5 is still the way it
It is. Because define that exponent.
Oh, it's not.
is. Yes.
Hey, yeah.
This one?
Because the point doesn't equal though. I was like, this is so easy. You get 8. I was like, whoa, 3.
All right, friends, when next we see each other, you will have the pleasure of taking the first calculus.